in the function itself. We're going to take a look at 4 cases, 4 situations here, guys, and we've already kind of modeled those. We're going to take a look at what we call odd degree functions first, all right? Notice I'm not using degree like we did yesterday, all right? But we're just going to group all of these odd degrees together, because that's what's really kind of cool, is that these odd degree functions, something like x, that the degree is x to the first, those are our linear functions, x to the third, x to the fifth, they all have the same behavior, okay? They're kind of like a family of functions. We're then going to take a look at our even functions, all right? And so that includes the quadratics that we looked at today. But we also can take these patterns and turn and apply them to x to the 4th, x to the 6th, x to the 8th. Anything with an even degree. Remember, the degree is that largest exponent, right, guys? So we have a whole lot of other exponents in the problem. But when the largest exponent is even, it's going to follow a certain pattern. Now, I want to talk about leading coefficients with you. If we go back and look at the example here, what was our leading coefficient? What would the leading coefficient of that function be? Negative 1. And what was the leading coefficient of this one? Positive 1. What was the leading coefficient of this one? Negative 2. What was the leading coefficient of this one? Positive 3. So if you guys notice, I broke our leading coefficients into 2 patterns. We can have either a positive leading coefficient, or we can have a negative leading coefficient. All right? And what's pretty cool about positive and negative leading coefficients, they have the same effect on your function. So the positives are going to affect even and odd functions the same way. Negatives are going to affect even and odd functions the same way. So are we okay with this part of the table, guys? All right. Now what I want to do is introduce this. I hope you guys all know what this symbol is. What symbol is that? Infinity. This one has a negative in front of it, so this is negative infinity, and this one is positive infinity. So I'm going to talk to you guys about what this means. It says, as x approaches negative infinity, what is f of x going to do? Well, that f of x, guys, really is just talking about y. So what you're really talking about is, what is the y-axis doing? What is the y-coordinate of the function doing? So what we're trying to do is we're trying to look at, as x is negative, on this negative side, this is our negative infinity of a function, what is the y value doing? Is it going positive? Is it going negative? And then we say, as x is going to the positive side, as it's going to positive infinity, what is the function doing on this side? So basically what we're doing, guys, is splitting our graph into 2 parts, the left-hand side for the negatives and the right-hand side for the positives, which is how we've always looked at our x-axis. Positives on the right, negatives on the left. Okay? So let's go back, and we're going to take a look at our chart and see if we can use these 4 examples that we graphed to talk about what our function is doing. All right? So the first thing we're going to do is I'm going to put up the positive leading coefficient with the odd degree. So we're going to look at this first function here. All right? I want to split my graph down the middle. And so I'm going to start off by looking at this negative infinity side. What is this function doing? Is it going up or going down? It's going down. If it's going down, is that positive y or is it negative y? It's negative y. And is this function ever going to stop, guys? No, it's going to keep going. So it doesn't stop here at like negative 8. It keeps going. And so the way we're going to read that in our function is, because it's going down, because negative x's are going to negative y's, we're going to read our chart as x approaches the negative numbers, y approaches negative. It means y is going down. That's what the end behavior is. If it's a negative infinity, it's going to go down. Approaches? No, I didn't. I used the infinity symbol. So it's the same thing you guys have there. I just don't make mine real even there. If we go back and look now at the positive side of x, which direction is this going? As we go to positive infinity, where's our y going? It's going up, which means it's going to positive, and it's going to go to the positive infinity. So the nice thing about this positive coefficient is that these are going to match. On our odd functions, on the negative side of the graph, it's going to go to negative. On the positive side, it's going to go to positive. And that's what we know about those linear functions. So an example of a function that would fit this is I need a positive leading coefficient, so I could have something such as 3, and I need to have an odd degree, so I could have x to the 7th. So if we were to graph y equals 3x plus 7, it's going to be going down on the negative side, it's going to be going up, it's going to be positive on the left-hand side. All right? And so you guys are going to be describing the end behaviors of these graphs to us for your homework tonight. If you go take a look at the second example, where we had a negative leading coefficient, we take a look at that one, it was the exact opposite. On the negative side of x, where was y at? Y was in the positive side. On the positive side of x, where was y headed? Down to the negatives. And so let's think about what that means, guys, because I do need you to do a little bit of thinking with this. Negatives usually mean the opposite, correct? So when we were at negative infinity, we went to positive infinity. If we're at positive infinity, we have to go down to negative infinity. And so this is what I remember telling some students last year, guys. This leading coefficient is what we multiply by, correct? So if I do a positive times a negative, what do I get? A negative. If I do a positive times a positive, what do I get? A positive. If I do a negative times a negative, what do I get? A positive. And if I do a negative times a positive, what do I get? A negative. So you can use those leading coefficients to help you figure out where you're going. But what you have to know, ladies and gentlemen, is that this coefficient is going to determine what direction you go in for your odd degrees, okay? This is only going to work for my odd degrees. And those are usually the hardest ones. So if we were to look at an example of what a function is that would have this in behavior, I have to have a negative coefficient because they're going in opposite directions of each other. So maybe negative, and then it has to be an odd degree. So negative x to the third plus 3. It doesn't have to be just a leading coefficient with its exponent, guys. You can have other terms in the problem, all right? But these are usually the ones that we struggle with the most. But what you need to keep in mind is that odds are opposite of each other. One is always positive while the other is negative. The same with our lines. One was positive, one side was negative. They're always going in opposite directions. And to figure out that direction, you're going to multiply by your leading coefficient, okay? I'm going to switch gears now, guys, and we're going to take a look at even functions. Now, our even functions, I think, are a little bit easier, because if I look at my leading functions, what do you notice about the direction of this graph? They're both going up, right? And if I look at my next one, they're both going down. And so the nice thing about even functions is if everything is even, like if I have candy and I'm trying to make it even for my kids, I give them all the same amount, right, guys? All right? So if I have an even function, our end behavior is always going to be the same. They're both going to be either positive infinity or they're going to be negative infinity. Now, what's going to determine that? It's going to be your leading coefficient. So if I have a leading coefficient that's positive for my even function, Michelle, these both are going to go to positive infinity. So if it's even, and this is where you guys have to think, and this is where those of you who aren't listening right now, and I can tell because some of you are staring off into space, even means they are the same. So they're going to go in the same direction, either to positive infinity or to negative infinity. And this tells us what it's going to be. So for this last one, if I have a negative leading coefficient and it's even, then they both have to go to negative infinity. All right? You guys have a couple of options. You can memorize this chart. I'm not a big fan of memorizing because I did a lot of that in high school and I didn't take any of it with me. Or you can keep asking questions about what these mean and how they affect it. I will tell you guys, in all of your all of your tests and quizzes, I give you this beginning part, okay? So the part that's typed in there, I will give that to you to get your brain started on that for the x approaches negative infinity and x approaches positive infinity, okay? I want to give you guys a couple of quick examples. So a positive function With an even degree, we would have f of x is equal to x to the 6th plus 5x to the 5th. Notice, guys, it doesn't have to be all evens. So I can throw odd numbers in there, I can throw odd exponents in there. But that first term has to be an even exponent. Is that you? Okay, then shut it up. And then here I just need to have a negative leading coefficient, so I could have negative x to the 4th, and then I could still have a negative 3x to the 3rd in there. It doesn't matter what comes after it, I'm just focused there. So let's take a look at what your homework's going to look like and some of the things I'm going to expect you to do with this. We want you to graph this polynomial function. So you guys are going to go to your calculator, and you're going to type in negative x to the 3rd plus 2x squared plus x plus 1. So you guys should have your graphing calculators already, correct? So start typing it in there. I got to get mine out of my bag. So what do we have here? We have negative x to the 3rd. Were you asking something, Hunter? Okay. All right. And then, ladies and gentlemen, once you do that, you can hit graph. And so we can kind of see. Now, before I hit graph, guys, I want you to tell me, are they going in the same direction or are they going in opposite directions? Opposite, because it's an odd exponent, so odd for opposites. And because this is negative, it means the negative side is going up, the positive side is going down. So if we look at our graph of that, that should be what I see. I should have some part of my graph over going up. Notice it turns, and then it starts going down. So it matches that in behavior that I need. This was a decent graph, ladies and gentlemen, because everything showed up on your screen. Not everything is going to show up. When we start getting x to the 5th, x to the 6th, we may not see them. But this is a pretty nice graph that you guys can go through and do a sketch of. To get a little bit better sketch, what I want you guys to do is to go to your table of values and get a couple of decent points to graph. I don't want you graphing negative 15. But could you graph these 4 points there with the y equals to 3, 1, 3, and 3? So could we graph these on our graph very easily? So on your graph paper, you guys are going to graph negative 1, 3, 0, 1, 1, 3, and 2, 3. And so this is what I had to do in high school, so I am dating myself. I would have to go and plug in 1, plug in 0, plug in negative 1. We would use those values. That's what our math teacher told us to use because they were small numbers and they'd usually give us easy ones to graph. And so then we would plot those points, negative 1, 3. Here I didn't have a graphic calculator. And then what I had to use was what I knew about my in behavior. I knew because this was negative, my graph was going to be going up on the negative side. So I made sure it was going up. It's going to turn, and it's going to turn again, guys. You're never going to connect with straight lines. And because this was negative, on the positive side, it was going to go down to the negatives. So that's what our graphs will look like. Okay? So I would like you guys to try the next one on your own. I want to see the couple of points that you plot, and then I want you guys to use your in behavior. Do it with Jalen. I think we had, was it negative 2, negative 1? Was negative 2, negative 1 the first point, get one of the points?
Yeah, negative 2, negative.
And then negative 1, negative 3, and then 0, 1, and then 1.
1, negative 1.
1, negative 1, and then was it 2, 3?
Yeah.
All right, so we graph those points, negative 2, negative 1. We graph negative 1, negative 3, 0, 1, 1, negative 1, and then 2, 3, 1, 2, 3. What you need to realize, guys, is our graph is always connecting like a snake like this. These get to curve now that they're not linear. And so what I need to decide is, and like I said, I think based on the windows that you guys have and the functions you have, you should be able to see this. But I need to know, should my graph keep going up or should it eventually go down? Because on your screen, they're both going up, right, guys? But could this function function go up and then all of a sudden come off the screen and be going down?
Yeah.
It could if we don't pay attention to our end behavior because you're not zoomed all the way out. But let's go back and look at our end behavior. This is an even function, right guys? 4 is an even number. So they're both going to go up or they're both going to go down, correct? What does this positive 1 tell me about the direction? It's going to go up. So you guys can just keep them going up. All right? Ladies and gentlemen, don't be so arrogant as to assume that your graph screen is showing you all of the graph. That graph could do a lot of things outside of your viewing window. But if I use my end behavior, that it's going to keep going up, you've got enough here for graphing. Okay? So let's take a look now at the last one with matching. And yes, ladies and gentlemen, you could go through and graph all of these. I would like to be a little bit quicker with my work, and so I'm not going to do these by typing them into the calculator. So you can do that on your own and take a little bit longer. You can listen. I start here. I say this is even, so it's going to be both up or both down, correct? And if this is 2 is positive, they're both going to be what, Nathan? Up or down? Up. So I'm looking for a function where they're both going up. So which one am I choosing? C. I go over to 2. This is an odd function, right? So they're going to go in opposite directions. 1 up and 1 down. But because this is a negative 3, that means the negative side is going to be positive. It's going to be going up because a negative times a negative should give me a positive. So on this negative side, so we agree with D. Pretty easy. Now it becomes really quick because this is even, and what's the only even function I have left, guys? B. And does it match? This was negative, so this should be going down. And then last but not least, I hope most of you do your mathing this way, 4 is A. Now, if you don't want to do that much thinking, could you be a monkey and go through and just type them in like a little machine? You sure can. I think a lot, or I know I think a lot faster than I type, guys. Okay? So I want you guys to practice that. It's going to come in handy for the upcoming quizzes on Friday. So for your assignment tonight, you guys are going to do a book assignment again.